Good day, guys. I hope you're all doing so well. Grade 12 and grade 11s. Electrostatics. Question 2, 2017, September control test, grade 11, Free State. Question 2. Now, the statement says for question 2, two small identical metallic spheres Q1 and Q2 on isolated spheres are separated by a distance of 0.4 meter as shown. Again, these two charges are separated by 0.4 centimeter, and Q2 and point Y are separated by 0.2 centimeter. And Q1 is plus 14 microcoulomb and Q2 is negative 12 microcoulomb. Now the question says to 2.1 guys. 2.1 says to you that please draw the resultant electric field patterns of Q1 and Q2. The resultant electric field. Don't be scared by the word resultant. It means the results or the overall electric field pattern of Q1 and Q2. How about electric field pattern? You think about the magnetic field again. Drawing those lines that shows what between these two charges, which charge will carry the magnets outside and which one will receive, which one will give out and which one will receive between Q1 and Q2 again. Let us draw the 2 points again, the charges, the two charges there. Now, this one is positive and this one is negative. Just know that they attract one another. They don't repel again. Negative charges, like charges repel, unlike charges attract. So now they will attract one another, these two here. So you now go to positive. The function of positive is to release. It releases. You throw the arrow. The first arrow, you throw it in between. They attract one another. Then the negative charges, it releases. The positive charges, the negative charges, it absorbs. So you can throw the opposite side. It absorbs. That means the charges comes inside the negative charges. Then you throw another one. The positive charges, they do what? They release. So the positive charges, they release. Yes, guys, this is how we draw the electric field around. So the positive charges, they release. The negative charges, they do what? They put everything that comes from the positives inside. This is how we draw the electric field around these 2 points, guys. Very simple and straightforward. Let us go to the next question. I hope you understand what's happening here. The next question, it's so simple, Leona. 2.2, 2.1.2. It says that 2.1.2, it says that calculate the electric field at point Q2. Calculate the electric field at point Q2. The formula for electric field is electric field at a point is E is equals to K Q over R squared. Which means it says that at a point, which means point Q2. They told you at this point. What is the electric field at this point? Well, I use only this point to calculate the electric field at that point. Simple. This is equal to, what is the value of K? Is 9 it's our constant. 9 times 10 to the power 9 multiplied by, what is the value for our Q? Is 12. Remember, this negative 12, it just shows the charge, not the value actually. Our value is positive 12. It's 12 times 10 to the power negative 6. Don't involve the negative sign, please, guys. That negative shows the direction of the force, not of the charge, not the value or whatsoever. Then the distance, remember the distance there between these 2 points the electric field at this point Q2 with results of this one. That means the distance between this point and this one, this point Y, is 0,2 at the electric field at a point from Q2 at this point, actually from Q2. So the distance between the 2 points is 0,2. So you want to remember, from centimeter to meter, you divide it by 100. So 0,2 divided by 100 squared. Remember this squared, the distance squared from centimeter to meter divided by 100. Therefore, you press a calculator here. On the calculator, we will 9 times 10 to the power 9, close bracket 12 times 10 to the power negative 6. On the bottom, 0,2 divided by 100 squared outside. Our answer there is 2,70 times 10 to the power 10. Yes, newtons per coulomb. Yeah, this is the answer for our question. I hope you are still with me here, guys. Let's go to the last question, 2.2.1. Let's go to the last question. The last question, 2.2.1. I'm going to remove this one here. The last question, 2.2.1. It's so simple. 2.2.1. I'm going to read the statement. I'm going to read the statement for you. 2.2.1. 2.2.1. It says that 2 magnitude. Oh, excuse guys. 2.2. I guess it says you must define what is the describe or write or define Coulomb's law in words. Define Coulomb's law in words. Coulomb's law, guys. Coulomb's law, you must know it by heart before you can enter into the examination. Please, guys. What is Coulomb's law? Coulomb's law, it is the magnitude of the electrostatic force exerted by one point charge on another point is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Then you are done. Please know the Coulomb's law by heart. It's going to appear in the examination. Then 2.2.1, it says that, okay, 2.2 basically, we have done with 2.2.1. 2.2, it says that the same charges Q1 and Q2, the very same charges Q1 and Q2 as in the question 2.1 are now placed at an angle of 90 degrees with respect to the third charge P. The charge on P is 10 plus 10 microcoulomb, and the distance are indicated in the diagram. So now we're going to draw a diagram here. So we have this point here, and this point is another point here, and there's another point here, guys. Now they're saying, okay, there's Q1, the very same charges is equals to negative 12 microcoulomb, and this one is equals to 14 microcoulomb, and we have a point P here. This point P is equals to 10 microcoulomb. Guys, the question says that you must calculate the magnitude of the net electrostatic force. Okay, this one I think is very important. I think it's very important to know to calculate the net electrostatic force. Very important question, very key question. This one, it's a very key question. Calculate the net electrostatic force, means the total electrostatic force. And yeah, this basically means you must determine here our radius, our hypotenuse. So you need to find the electrostatic force from point Q1 to P and the electrostatic force from point P to Q2 using Coulomb's law, and determine our radius squared there. That is our aim. But we can literally find the total electrostatic force individually between Q1 and P together with Q2. Guys, let us do that. Now, guys, so now, electrostatic force on Q1 and P is equals to K Q1 times Q2 all over R squared is equals to, what is the value of K? Is 9 times 10 to the power 9. What is the value of Q1? Is 14 here. Remember, this microcoulomb is equals to 10 to the power negative 6 here. So it's times 10 to the power negative 6, close bracket, open bracket. Q2 is P here, which is 10 times 10 to the power negative 6 here. All divided by R squared. R squared, guy, the distance between Q1. Okay, I forgot to write the distance. Let me just write it. Very, very key. It's important to write the distance. The distance is 10 centimeter, and the distance between P and Q2 is 15 centimeter. So now, centimeter to meter all the time. So we're gonna divide both sides. We're gonna divide by 100. So it's 10 divided by 100 squared. Our answer, guys. So we're gonna say our answer there is 9 times 10 to the power 9. 14 times 10 to the power negative 6. 10 times 10 to the power negative 6. Then close bracket. 10 divided by 100 squared. Our answer is 9 times 10 to the power 9, 14 times 10 to the power negative 6, 10 times 10 to the power negative 10, 10 to the power 0,1 here. It's 126 newtons. Then another one is force on P to Q2 here is equals to, obviously I'm going to substitute, but I'm going to use P and Q here. P I want to get I want to take 9 times 10 to the power 9 here, multiplied by 10 here. 10 times 10 to the power negative 6 again multiplied by 12. Remember, 12 does not go with the sign, it's just positive there. 12 times 10 to the power negative 6, all divided by distance between P and Q2 is 15. 15 centimeter means 15 divided by 100 squared. Then the final answer there is 9 times 10 to the power 9, 10 times 10 to the power negative 6, 12 times 10 to the power negative 6. So it's 15 divided by 100 squared. The answer is 48 newtons. but they say that determine the net. That means you must, how about the net? You must add the two. You must add the two. How about net? The total, you must add them. But now we have a 90 degree here. And we need to find from Q1 to Q2. We have a 90 degree angle per throgas. Therefore, net electrostatic force. Therefore, F net is equals to, not MA. So F net is equals to F net squared. How about net? The total. But here we have a 90 degree angle. It means we want to find the radius, our hypotenuse side. So it will go F net squared is equals to adjacent plus opposite, which is 126 squared for our adjacent plus 48 squared. Then 126 plus 48 squared give 18,018. Therefore, the F net squared. I need the F net. I introduce the square root on both sides. Square root, and therefore F net give guy answer around to square root 134,83 newtons. You are done. This is the answer for our question. Thank you guys for your ears and eyes of watching and listening, and thank you for writing down your notes. Thank you for today. We will continue up on the next part of our series of preparation for examination. Ngiyabonga. Thank you very much. You can request any question on the comment section, or you can send them on my private number. You can find them on the profile. So you can send any question you want, guys. Thank you very much.